The chip crisis: how tariffs and supply chain issues are reshaping U.S. semiconductor manufacturing. Introduction. The global semiconductor industry, often described as the backbone of the modern digital economy, has faced unprecedented challenges in recent years due to supply chain disruptions and escalating trade tensions. The chip crisis, a term coined to describe the severe global shortage of semiconductors that began during the COVID-19 pandemic, has exposed vulnerabilities in the global supply chain, particularly the United States' heavy reliance on foreign manufacturers. Tariffs, particularly those imposed on Chinese imports, have played a significant role in reshaping American factories, driving investment in domestic semiconductor production, and altering manufacturing processes, costs, and output. This article delves into how these tariffs and supply chain issues have transformed the U.S. semiconductor industry, with a focus on companies like Intel, and examines the broader implications for American manufacturing. Real-world examples, such as the boost to U.S. steel production and the surge in domestic semiconductor investment, illustrate the complex interplay of trade policies and industrial strategies. The chip crisis: origins and context. The semiconductor industry is critical to modern technology, powering everything from smartphones and computers to automobiles and medical devices. Semiconductors, often referred to as the heartbeat of the digital economy, are foundational to innovation and economic competitiveness. In 2024, the global semiconductor market was valued at $627 billion, with projections to reach $1 trillion by the end of the decade. However, the industry's complex global supply chain, heavily concentrated in Asia, has made it vulnerable to disruptions. The chip crisis emerged in 2020, driven by a confluence of factors. The COVID-19 pandemic disrupted manufacturing and logistics, surging demand for electronics strained supply, and geopolitical tensions, including U.S.-China trade disputes, exacerbated shortages. The United States, which produces only 12% of the world's semiconductors, relies on foreign manufacturers like Taiwan Semiconductor Manufacturing Company, TSMC, for 80 to 90% of advanced chips. This dependency became a liability during the crisis, as supply chain bottlenecks led to production halts in industries like automotive, where chip shortages forced automakers to cut output in 2021. Tariffs, particularly those imposed by the Trump administration in 2018 and continued under the Biden administration, have further complicated the semiconductor supply chain. In 2025, the Trump administration's reimposition of tariffs, including a 25% levy on semiconductors and up to 145% on Chinese imports, has accelerated efforts to reshore manufacturing to the U.S. These tariffs aim to incentivize domestic production but have also increased costs and disrupted global supply chains, forcing companies to adapt there. Tariffs and their impact on the semiconductor industry. Background on tariffs. Tariffs are taxes imposed on imported goods, designed to make foreign products more expensive and less competitive than domestically produced ones. In the context of the U.S.-China trade war, which began in 2018, tariffs were used to address perceived unfair trade practices, reduce the U.S. trade deficit, and encourage domestic manufacturing. By 2025, the Trump administration had imposed tariffs on a wide range of goods, including a 25% tariff on semiconductors, 50% on steel and aluminum, and up to 145% on Chinese imports. These tariffs have had profound effects on the semiconductor industry, which relies on a complex global supply chain for raw materials, equipment, and components. The Biden administration had previously raised tariffs on Chinese semiconductor imports from 25% to 50% in 2024, citing national security concerns and the need to bolster domestic production through initiatives like the CHIPS and Science Act. The Trump administration's 2025 tariffs, however, are broader and more aggressive, targeting not only China but also allies like Taiwan, which supplies the majority of advanced chips. These policies have created both opportunities and challenges for U.S. semiconductor companies like Intel, which are investing heavily in domestic manufacturing to reduce reliance on foreign supply chains. Impact on manufacturing processes. The semiconductor manufacturing process is one of the most complex and capital-intensive in the world, involving hundreds of steps, specialized equipment, and a global network of suppliers. Tariffs have disrupted this supply chain, forcing companies to rethink their manufacturing processes. Key impacts include supply chain diversification. Tariffs on Chinese imports have prompted companies to diversify their supply chains away from China. For example, Intel has partnered with TSMC to supplement its U.S. manufacturing arm, reducing dependence on Chinese-sourced components. This shift requires reconfiguring supply chains, which can involve new suppliers in countries like Vietnam, India, and Malaysia. However, these transitions are costly and time-consuming, often requiring new logistics networks and quality assurance processes. Increased use of domestic suppliers. Tariffs have made imported components, such as chemicals and raw materials, more expensive. As a result, companies are prioritizing domestic suppliers where possible. For instance, Intel's expansion of U.S. factories in Arizona, Ohio, and Texas includes efforts to source materials locally, reducing exposure to tariff-related costs. However, the U.S. lacks sufficient capacity for about 60% of the 100-plus chemicals and materials needed for semiconductor production, limiting the extent of localization. Adoption of Design-to-X (DTX) strategies. To mitigate tariff costs, semiconductor companies are adopting Design-to-X (DTX) approaches, redesigning products to eliminate high-tariff components or reduce reliance on costly inputs. This involves collaboration with supply chain partners to identify cost-saving opportunities, such as using alternative materials or optimizing manufacturing processes to minimize waste. Investment in automation and efficiency. The rising costs of imported equipment and components have pushed companies to invest in automation and advanced manufacturing technologies. Intel, for example, has implemented advanced robotics and AI-driven quality control in its new U.S. factories to improve efficiency and offset higher input costs. These technologies enhance yield rates and reduce production errors, but they require significant upfront investment. Impact on costs. Tariffs have significantly increased the cost structure of the semiconductor industry, affecting both manufacturers and downstream industries. Key cost-related impacts include higher input costs. Tariffs on raw materials like steel, aluminum, and rare earth minerals have driven up the cost of semiconductor production. For example, steel and aluminum tariffs have increased the cost of constructing new fabrication plants, fabs, which can cost over $30 billion each. Additionally, tariffs on chemicals and equipment, such as lithography machines from ASML, have raised production costs, as these inputs are often sourced from countries like Japan and the Netherlands. Increased prices for consumers. The pass-through of tariff costs has led to higher prices for semiconductor-dependent products. The Consumer Technology Association estimates that a 60% tariff on Chinese imports could increase the price of laptops and tablets by up to 46% and smartphones by up to 26%. Nvidia, for instance, raised GPU prices by 15% in 2025 to offset tariff costs, impacting the cost of AI infrastructure and consumer electronics. Compliance and administrative costs. Navigating the complex tariff regime requires significant resources. Companies must hire additional personnel to manage compliance, track tariff-exempt components, and negotiate with suppliers. Industry estimates suggest that chip equipment makers could face over $1 billion in tariff-related compliance costs, including lost revenue from missed sales to overseas rivals. Capital investment requirements. The push for domestic manufacturing has spurred massive investments in U.S. fabs. Intel announced a $100 billion investment in 2024 to build and expand factories in Arizona, Ohio, and Texas, supported by a $7.86 billion federal grant from the CHIPS Act. While these investments reduce long-term tariff exposure, they increase short-term costs, as new fabs take years to become operational and profitable. Impact on output. The chip crisis and tariffs have had mixed effects on semiconductor output, with both short-term disruptions and long-term potential for growth. Key impacts include short-term supply disruptions. Tariffs have caused delays and shortages as companies scramble to reconfigure supply chains. For example, the 2021 chip shortage, exacerbated by tariffs and pandemic-related disruptions, led to a $2.8 billion production increase in U.S. steel industries but a $3.4 billion production decrease in downstream industries like automotive due to higher input costs. Semiconductor output was similarly constrained, with U.S. imports of chips from China dropping 26% since 2018. Long-term output growth. The CHIPS Act and tariff-driven reshoring efforts are boosting domestic semiconductor output. By 2032, the U.S. is projected to produce 28% of global chips, up from 12% in 2025, driven by investments from Intel, TSMC, and Micron. Intel's Ohio fab, which broke ground in 2023, is set to start production in 2025, creating over 10,000 jobs and increasing U.S. chip capacity. Shift to advanced chips. Tariffs have incentivized investment in advanced chip production, particularly for AI and data center applications. NVIDIA's $500 billion investment in U.S. AI chip manufacturing, announced in April 2025, reflects the push to produce high-value chips domestically. However, advanced chips, sub-5 nanometer, remain challenging to produce in the U.S. due to limited technical capacity and reliance on foreign equipment. Regional production shifts. Tariffs have redirected production to tariff-free zones like Mexico and Canada, where goods compliant with the USMCA face 0% tariffs. This has led to increased semiconductor assembly in North America, but it also complicates supply chains, as components may still originate from tariff countries like China or Taiwan. Real-world examples. Boost to U.S. steel production. Tariffs on steel and aluminum, initially imposed in 2018 and raised to 50% in 2025, have significantly boosted U.S. steel production. A May 2023 report from the United States International Trade Commission found that steel tariffs led to a $2.8 billion production increase in protected industries. U.S. Steel, for example, restarted idled furnaces in Pennsylvania within months of the 2018 tariffs, increasing output and creating jobs. This resurgence has indirectly supported the semiconductor industry by providing domestic steel for fab construction, reducing reliance on imported materials. However, the downstream impact has been less positive, with a $3.4 billion production decrease in industries like automotive due to higher steel prices, illustrating the trade-offs of tariff policies. Driving domestic semiconductor investment. The CHIPS Act, combined with tariff pressures, has spurred unprecedented investment in U.S. semiconductor manufacturing. Intel has been a key beneficiary, leveraging federal grants and tariff incentives to expand its domestic footprint. Specific examples include Intel's Arizona expansion. Intel is investing over $20 billion in 2 new factories in Arizona, supported by CHIPS Act funding. These facilities aim to produce advanced chips, reducing reliance on TSMC and mitigating tariff-related costs on imported semiconductors. Ohio fab development. Intel's Ohio fab, which broke ground in 2023, is set to begin production in 2025. The $20 billion project is expected to create 10,000 jobs and increase U.S. chip output, addressing the chip crisis by boosting domestic supply. TSMC's U.S. investment. TSMC, the world's largest chipmaker, announced a $100 billion investment in U.S. production over the next 4 years, including a new fab in Phoenix. This move, driven by tariff pressures and U.S. incentives, aims to produce 80 to 90% of the world's advanced chips domestically by 2032. NVIDIA's AI chip push. NVIDIA's $500 billion investment in U.S. AI chip manufacturing, announced in April 2025, reflects the urgency of reshoring critical technologies. Tariffs on Chinese imports and the need for secure AI infrastructure have driven NVIDIA to prioritize domestic production, despite higher initial costs. These investments highlight how tariffs, combined with government incentives, are reshaping the U.S. semiconductor landscape, though challenges like high costs and technical limitations persist. Broader implications for American manufacturing. The transformation of the semiconductor industry has ripple effects across American manufacturing, influencing sectors like automotive, consumer electronics, and data centers. Key implications include job creation and economic growth. The CHIPS Act and tariff-driven reshoring are creating thousands of high-paying jobs. Intel alone has generated over 10,000 jobs through its U.S. fab expansions, while TSMC and Micron's investments are expected to add thousands more. These jobs bolster local economies in states like Arizona, Ohio, and Texas. Increased costs and inflation. Tariffs have driven up costs for manufacturers and consumers, contributing to inflationary pressures. The Tax Foundation estimates that 2025 tariffs amount to an average tax increase of $1,300 per U.S. household, with semiconductors and electronics facing significant price hikes. This could reduce consumer purchasing power and impact demand for tech products. Supply chain resilience. By reducing reliance on Chinese imports, tariffs are fostering more resilient supply chains. Companies are investing in redundancy, securing long-term supplier agreements, and diversifying production to tariff-free zones like Vietnam and India. However, these shifts require significant time and capital, and short-term disruptions remain a challenge. Global competitiveness. The U.S. aims to regain leadership in the global semiconductor market, but tariffs risk making U.S. chips less competitive due to higher production costs. The Information Technology and Innovation Foundation, ITF, warns that blanket tariffs on semiconductors could harm U.S. leadership in AI, data centers, and other digital industries, as higher costs deter investment and innovation. Downstream industry impacts. Industries reliant on semiconductors, such as automotive and consumer electronics, face higher costs and supply constraints. For example, tariffs on steel and aluminum have increased car prices by an estimated $4,711, while chip shortages continue to limit automotive output. These downstream effects highlight the interconnected nature of modern manufacturing. Challenges and criticisms. While tariffs have driven domestic investment, they are not without criticism. Key challenges include economic costs. Tariffs have led to job losses in downstream industries, with a 2018 steel tariff creating 8,700 jobs in the steel sector but costing 75,000 jobs in manufacturing due to higher input costs. Similar risks exist for semiconductors, where increased costs could outweigh the benefits of reshoring. Limited domestic capacity. The U.S. lacks the technical expertise and infrastructure to fully replace foreign chipmakers. For example, advanced sub-5 nanometer chips, critical for AI and high-performance computing, are still predominantly produced by TSMC in Taiwan. Building this capacity domestically will take years and billions of dollars. Global retaliation. China's retaliatory tariffs, such as the 125% duty on U.S. imports in 2025, have disrupted American exports and strained global supply chains. China's restrictions on rare earth minerals, essential for chip production, further complicate reshoring efforts. Consumer impact. Higher prices for electronics and other semiconductor-dependent products could reduce consumer demand, slowing economic growth. The National Retail Federation estimates that tariffs could cost consumers $6.4 to $10.9 billion annually for appliances alone. Complexity of supply chains. The semiconductor supply chain is highly specialized, with countries like Japan providing 90% of photoresists and over 50% of photomasks. Tariffs on these inputs increase costs without clear alternatives, undermining the competitiveness of U.S. fabs. Future outlook. The future of U.S. semiconductor manufacturing depends on balancing the benefits of tariffs with their economic costs. Key trends to watch include continued investment. The CHIPS Act and tariff incentives will likely drive further investment in U.S. fabs. By 2032, the U.S. is projected to produce 28% of global chips, reducing reliance on foreign suppliers. Companies like Intel, TSMC, and Nvidia will continue to expand domestic capacity, supported by government grants and tax credits. Technological advancements, advances in automation, AI, and manufacturing processes will help offset tariff-related costs. Intel's adoption of AI-driven quality control and TSMC's investment in cutting-edge fab technologies will enhance efficiency and output. Global trade dynamics, the US-China trade war and retaliatory tariffs will continue to shape global supply chains. Negotiations, such as the 90-day tariff pause agreed upon in May 2025, could lead to a more stable trade environment, but deep disagreements make a permanent resolution unlikely. Policy adjustments. The Trump administration's tariff strategy may evolve in response to economic pressures. For example, exemptions for USMCA-compliant goods and certain consumer electronics suggest flexibility, but broader tariffs on allies like Taiwan could strain strategic partnerships. Consumer and industry adaptation. As prices rise, consumers and businesses will adapt by prioritizing cost-effective products or delaying purchases. Semiconductor companies may focus on high-margin products like AI chips to offset costs, potentially shifting market dynamics. Conclusion. The chip crisis and tariffs have fundamentally reshaped U.S. semiconductor manufacturing, driving investment in domestic factories while increasing costs and complicating supply chains. Companies like Intel are at the forefront of this transformation, leveraging CHIPS Act funding and tariff incentives to expand U.S. production. Real-world examples, such as the boost to U.S. steel production and massive investments in semiconductor fabs, highlight the potential for tariffs to revitalize American manufacturing. However, challenging